Okay, everyone. The topic for this lesson is the sigma bond and the pi bond. So two types of bond that you have to recognize. So first one is the sigma bond, and the second one is the pi bond. The symbol for sigma would go something like this. And then for pi, it's just mathematical constant kind of symbol, but it doesn't mean the same thing. So how do you recognize sigma bond and pi bond given a molecular structure? So let's talk about sigma bond first. Let me read this with you. The sigma bond symbol will look like that, are the strongest type of covalent chemical compounds. They are formed by head-on overlapping between atomic orbitals. And let me show you what that means. So you can make three types of sigma bonds. Remember s orbitals and p orbitals. So first type of sigma bond that you can make would be, as they say, head-on overlapping between s orbital of one atom and s orbital of another atom. And they will give you something like this. And that is your sigma bond. In fact, SS head-on overlapping is the strongest sigma bond. You can also make sigma bond by the overlapping, head-on overlapping between the s orbital of one atom with a p orbital of another atom in this orientation. And that is your sigma bond as well. You can also have p orbital of one atom overlapping head-on with another p orbital of another atom this way. And that is also a sigma bond. So three ways to make sigma bonds. Strongest of them all would be the SS head-on overlapping bond. So here you have a visual as to what it will look like. So here's two carbon atoms. And in the middle, you have overlapping of the s orbitals. And the resulting bond looking like that is your sigma bond. Another visual is at the bottom of the page. So head-on between two s orbitals of two different atoms, head-on overlapping between two p orbitals coming from two different atoms, and also overlapping, head-on overlapping between the s orbital of one atom with p orbital of another atom. And this is pz. All of these combinations will give you sigma bonds. And SS overlapping being the strongest sigma bond. Now, let's look at what do we mean by pi bond. What do we mean by pi bond? It doesn't mean the same thing as the mathematical constant pi. So let's read this passage together. When two atomic orbitals of pi symmetry, okay, and it doesn't have to be necessarily a p orbital, combined, they form a pi bond. An orbital of pi symmetry is defined as having electron density above and below the node. And we'll look at what that means in a second. Through the nuclei of the bounding atoms. So here, consider these two atoms, carbon, carbon. So here's your sigma bond. Here's your sigma bond, S and S head-on overlapping, let's say. So you may have another bond resulting from overlapping. Now, it's not head-on, notice. It is the side-by-side overlapping. So let's say this carbon has a pi bond, I'm sorry, p orbital, looking like this, with another p orbital of another atom looking like this. So when they bond, overlap, side by side, not head on, side by side, resulting in a bond that will look like this, p overlapping above and below, above and below. That is one bond. So when we say pi bond, it's the overlapping of top and the bottom. And together collectively would be one pi bond. Let's read on. The single covalent bonds or sigma bonds, we've talked about this. So in any molecule, any first single bond would be called sigma bond. When you have a double or triple bond, for example, in double bond, first one would be your sigma bond. The second bond of the double bond is your pi bond. Pi bonds can never be of single bond. When you have a triple bond, like here, that's a triple bond. You have first bond being a sigma bond, and then you have a second bond of the triple bond would be one set of two overlapping regions. And then you have a third one, the last one of the triple bond, overlapping two regions. So collectively, this would be a triple bond, and this would be a double bond. Okay, let's read that one more time. So single covalent bond or sigma bonds, while the multiple bonds, meaning double and triple, consists of the first one being the sigma bond, then the remainder of the bonds being the pi bonds. For example, carbon monoxide, carbon and oxygen connected by a triple bond, so they would be like this. Okay, and then the first one, let me just read this. There is one sigma bond and two pi bonds. And you would say one sigma, the first one, and then you'd have two pi's. And collectively, you would have triple bond. A single pi bond is weaker than a single sigma bond because there is less orbital overlapping. After all, for the pi bond, it is side-by-side overlapping instead of head-on overlapping. However, each successive pi bonds added on top of a sigma bond would make the bond stronger. Okay, so that means double bond is stronger than the single bond. Triple bond is stronger than double bond. But the sigma bond alone would be stronger than any pi bond alone. So let's kind of summarize at the bottom here. So if you have any single bond, okay, so we would say, oh, that's one sigma bond. When you have a double bond, first one will always be a sigma bond, and the second one is the pi bond. If you have triple bond, first one, like before, is always the sigma bond. The rest of the bond, the second and the third one, would be your pi bonds.